Welcome to today's lesson. My name is Siamasaka Kilian Dens, and so today I'm going to take you through the lesson in chemistry. We'll basically look at oxidation and reduction reactions. And so we go straight into the lesson for today. Well, what is oxidation? Basically, we can define oxidation um, in four different ways. Actually, we can say oxidation is the gain of oxygen or addition of oxygen to a substance. So when a substance is oxidized, we add oxygen to it. So we say oxidation has taken place. Then number two, when there is a loss or removal of hydrogen from that substance, then oxidation has taken place. That is in terms of hydrogen. In terms of electrons, oxidation actually is the loss of electrons from a substance. So if an element has lost electrons, then we say that element has been actually oxidized. Similarly, an increase in the oxidation state. When the oxidation state, as we'll see later, increases, then we say that substance has been oxidized. So these are the four different ways in which we can define oxidation. In terms of oxygen, addition of oxygen. In terms of hydrogen, oxidation is actually removal of hydrogen from the substance. In terms of electrons, it is the loss of electrons from a substance. And in terms of the oxidation state, it is the increase in the oxidation state. So we can now look at reduction. Reduction also in terms of oxygen is actually the removal of oxygen from a substance. While in terms of hydrogen, reduction is a gain of hydrogen by a substance. And also the gain of electron by a substance is known as also reduction. Also the decrease in the oxidation state. And so we have defined four ways here again on how we can define reduction. In terms of oxygen, it is the removal of oxygen from a substance. In terms of hydrogen, reduction is the gain or the addition of hydrogen to a substance. And in terms of electrons, it is actually the gain of electron by a substance. And in terms of the oxidation state, when the oxidation state reduces, then we say that substance has been reduced. And so now we go in detail in actually looking at exactly what happens when there is oxidation and reduction. And so here is an example of oxidation in terms of oxygen. We note that here red oxide reacts with magnesium to produce red and magnesium oxide. And so here we note that these are the reactants and this is what is produced or the products. And so we note that here actually the oxygen is added to magnesium so that magnesium now becomes magnesium oxide. And so we are saying magnesium is oxidized because it has gained oxygen by becoming magnesium oxide. So this is very important. And red oxide has been reduced because the oxygen has been removed from it to form in the product side red. And so red oxide, because it causes magnesium to be oxidized, is known as the oxidizing agent. So a substance that causes the other one to be oxidized is known as the oxidizing agent. In our case here, red oxide is the oxidizing agent because it causes magnesium to be oxidized. Similarly, the substance that causes the other one to be reduced is known as the reducing agent. And so here magnesium is a reducing agent because it causes red to be reduced. And so we notice that in this reaction where red oxide reacts with magnesium to produce red and magnesium oxide, there are two actual reactions taking place. There is the oxidation reaction as well as the reduction reaction. And so this is what is known as the redox reaction. So a redox reaction is a reaction in which oxidation and reduction takes place at the same time. Red means reduction and ox means oxidation. Again, so when a reaction actually has both reduction and oxidation, then such a reaction we call it a redox reaction because both reduction and oxidation takes place at the same time within the same reaction. So in terms of loss of electrons, now we define what oxidation is and also reduction is. We said actually earlier on, oxidation is the loss of electrons. So when a substance has lost electrons, we say it has been oxidized. And when it has gained electrons, we say it has been reduced, or that is a reduction reaction. And so here we see potassium. When it's on its own before it reacts with another substance, it has actually one electron in the outermost shell. And it means at this stage, it has not lost an electron. Similarly, chlorine has actually 7 electrons in the outermost shell before it reacts with another substance. And so here, for chlorine to be stable, it requires to gain 1 electron. And for potassium to be stable, it requires to lose an electron. And therefore, we notice that here potassium, actually, when it reacts with chlorine, it loses an electron. And therefore, potassium is oxidized, while chlorine gains the electron which is lost by potassium. And therefore, we say chlorine has been reduced. And so in terms of electrons, when a substance actually loses electrons, we say that substance has undergone oxidation reaction. While if a substance, in our case here chlorine, gains an electron for it to be stable, we say that actually it has undergone a reduction reaction. Now, in terms of changes in oxidation state, we say that actually oxidation is the increase in the oxidation state. And so, what is an oxidation state? For example, if an element has not reacted with another substance, it means that the oxidation state is actually 0. When it has lost, like this one has lost an electron, its oxidation state actually would be indicated by how many electrons that element or that substance has lost. In our case here, potassium, on the reactant side here, it has not lost any electron, and therefore its oxidation state is 0. while when it reacts with chlorine and it loses one electron, its oxidation state is 1. And we notice that the oxidation state has increased from 0 to +1. That is for potassium. And for chlorine, it has also reduced from 0 to -1. As you may be aware, 0 is greater than -1. And so the increase in the oxidation state is known as oxidation. And therefore, we are saying potassium here has been oxidized, or it has undergone oxidation reaction because its oxidation state has increased, while chlorine has been reduced because its oxidation state has reduced from 0 to -1. So the increase in oxidation state is actually known as the oxidation, as I stated earlier on, while the reduction in the oxidation state is known as the reduction. So here, as I indicated, potassium, the oxidation state has been gained from 0 to +1, while, and so we are saying potassium has been oxidized, while the oxidation state for chlorine has actually decreased from 0 to -1. And so we say chlorine has been reduced, as we indicated here. And so, in terms of hydrogen, oxidation actually is the loss of hydrogen by a substance. So if a substance has hydrogen in it and it loses the hydrogen, we say actually that is oxidation. For example, here we have ammonia. Ammonia actually, for example, here it has lost hydrogen. Here on the product side, it is only nitrogen. So meaning that oxidation has taken place here. So oxidation is the loss of hydrogen. So ammonia here has been oxidized. Okay, so ammonia has lost the hydrogen. Okay, and so similarly, a reduction or gain of hydrogen by a substance is actually known as reduction. And for example, here we have ethene. When it reacts with hydrogen, you form ethane. So we notice that ethene here has gained 2 atoms of hydrogen. They have increased, and therefore we are saying the reduction is the gain of hydrogen. So here, ethene has gained hydrogen actually. And so ethene has gained hydrogen to form ethane. And therefore this is a reduction reaction. And so I thought today we'll look at oxidation and reduction. One, in terms of actually oxygen, and in terms of hydrogen, and in terms of electron, as well as the oxidation state. This is very important, and so we need to actually go through it and put it to heart, so that actually it has no formula, but just to understand what oxidation and reduction are in terms of oxygen, hydrogen, the electrons, and the oxidation state. So I thank you. I hope you will continue subscribing to my YouTube. So in the next session again, we'll look at another interesting lesson. I thank you.